In this problem, we are being asked to use linear programming to solve kind of a complicated word problem here. And I've listed out the steps because there are a lot of steps involved in this. In a problem like this, there's usually some function that you either want to maximize or minimize. Maybe it's the amount of profit you get from something. Like in this problem, that would be a function that you'd want to maximize. Maybe it's a cost function, so you want to minimize it. But there's some function to write. Then you have some inequalities that represent the constraints on the whole system. In this case, there's only so much of the different types of coffee. That's going to lead to some inequalities that we need to write. We can't go over 1,584 ounces of grade A coffee and what we're dealing with here. Once you've got your constraints written, you graph those constraints, and then you find the vertices of the shape that's bounded by those inequalities, and then you test those points, those values in that original function. So that's a lot of steps. Let me show you how it's going to work on this one. First, let me just read through this. It says for a given week, Keith's Coffee House has available 1,584 ounces of grade A coffee and 1,440 ounces of grade B coffee. Okay, so over in a corner, there's a big sack of grade A coffee, a big sack of grade B. These are blended into 1 pound packages as follows. There's an economy blend that contains 3 ounces of A grade coffee and 6 ounces of B grade coffee, and a superior blend that contains 11 ounces of A grade coffee and 4 ounces of B grade coffee. Okay, so they're making different mixtures. The superior blend has more of the grade A, the economy blend has less of the grade A. Okay. Then it says there is a $1 profit on each economy blend package sold and a $4 profit on each superior blend package sold. So that's the information we're going to use to make our profit function. And then it says, assuming that the store is able to sell as many blends as it makes, how many packages of each blend should it make to maximize its profit for the week? All right, where to start with this thing? What's really important is that we know what is being asked for because those will be our variables. So at the end here, it says how many packages of each blend should it make. So we could call economy X. So that's your economy blend, and superior Y. So that's the first step. We have our X and our Y. Now, we need to maximize the profit. This sentence up here tells us about the profit. It says there's a $1 profit on each economy blend. Okay, so $1 times the number of economy blends would be 1x, or I'll just write it as x. And a $4 profit on each superior blend, so that would be 4 times y. That is our profit. However many of the economy blends we sell times 1, however many of the superior blends we sell times 4, that's going to be how much money we earn in profit. So this is the function we want to maximize. All right, so we've completed this. Step 1 done. Now, we need to write the constraint inequalities, and here it's a little tricky because you've got this 1,584 ounces of grade A, 1,440 ounces of grade B. We know we can't use up more than that, right? So there's going to be some kind of inequality where 1,584 is on this side, and then we have, it's got to be less than or equal to that we use up. But what do we put over here? We can't just put X or Y because each of these are a mixture. Well, what we want to do is look at these mixtures. It says the economy blend, so remember this is X, uses 3 ounces of grade A. And this 1584, that's the grade A we're talking about. So it's 3, we're going to be using up 3 times however many of these economy blends we make. So that's going to be 3x. And then it says how many grade B, but we're going to come back to that. The superior blend uses 11 ounces of grade A. So this is also going to use up 11 times however many superior blends we make. So that's how we get that inequality. So that's for the grade A coffee. The grade B coffee is going to go in the same way. We can't use up more than that, so we'll have a less than or equal to, and 1,440. Now grade B, the economy blend, that's our X, uses 6 of grade B. So this is 6x. and the superior blend uses 4, so 4y. So that is a little tricky way on how to get those constraints. There are two more constraints here that are of the common sense variety. You can't, you could make zero economy or zero superior, but you can't make a negative amount. So x has to be greater than or equal to 0, and y has to be greater than or equal to 0. Now we should be ready to graph these inequalities. So let's pull out a graphing program and see if we can do that. So let's see, we've got 3x plus 11y is less than or equal to 1584. And let me just zoom out here a bit. Okay. And then we've got 6x and 4y less than or equal to 1440. Okay, getting a nice shape already. And then we've got x is greater than or equal to 0. And we've got, oops, I capitalized that accidentally. There we go. And y is greater than or equal to 0. Okay, so these two are less than, so it's going to be under the two diagonal lines. So this is our shape right here. The next step is to find the vertices. We've got 0, 0 as a vertex. We're trying to maximize, so we're trying to get that profit function to be as big as it can be. So 0, 0 is going to make that profit function evaluate to 0, so I can safely ignore this one. But these others I should probably look at. Let me just take this one. So that's 240 comma 0, and this is 179.96. Just jotting these down, and 0, 144. So those points we're going to need to test. So let's go back to our profit function. And in looking at this profit function, uh, you know, the x is multiplied by 1, the y is multiplied by 4. So having more y's is going to make this number bigger. So I think 240 comma 0 is not going to work. Well, that's an easy one to plug in. It's just going to be 240. So 240 comma 0, that point evaluates in the profit function to 240. And let's see, let's try the 176.96. So when I plug that in, let's see, 4 times 96, 384. So that's going to be 560. Definitely bigger than 240. And let's try our 0, comma 144. I have a feeling this might be the 1. So 144 times 4 is, yeah, that's 576, I think. So that's definitely the biggest um, piece right there. So that maximizes our profit function. What this tells us is that we should make 0 economy packages. We should make all superior blend packages, and we should make 144 of those. So it asked us how many packages of each we should make to maximize the profit, and this is our answer. So that is a little bit of work with solving a word problem using linear programming.